When you watch Arno Rubik manipulate his famous invention, you are seeing a masterclass in three-dimensional spatial reasoning. Over the next few minutes, we will break down exactly how to calculate the surface area and the volume of any cube, ensuring you use the correct formulas and the right units of measurement every time. To follow along with this process, you will need a piece of scratch paper, a pencil, and a calculator. Mastering these two calculations provides the framework needed to understand three-dimensional shapes, allowing you to solve the foundational geometry problems that define spatial mathematics. A cube is defined by a single property. Its length, width, and height are all perfectly equal. We will use a side length of 5 centimeters for our working example. Because every edge is identical, we refer to this single variable as A. You may encounter problems that only provide the total volume or the interior diagonal. In those cases, do not use your standard formulas until you have worked backward to isolate the side length. Every subsequent calculation depends on this single value. Without the measure of A, the formulas for surface area and volume remain unsolvable. Step 2 is finding the surface area, which is the total two-dimensional space on the exterior of the shape. The formula is surface area equals 6a squared. Unfolding the cube into a flat net reveals it is composed of 6 identical squares. The area of one square is length times width, or a squared. To find the total surface area, multiply that single area by all 6 faces. Using our 5 centimeter variable, the equation becomes 6 times 5 squared. To avoid the most common error in this step, follow the order of operations. You must square the 5 to get 25 before you multiply by 6. 6 times 25 gives us a final numerical answer of 150. We have effectively measured the flat space required to cover the entire exterior. Step 3 is volume, the measurement of the three-dimensional space contained inside the shape. The formula is volume equals A cubed. We visualize this by building a physical foundation. A flat 5 by 5 grid of blocks creates a base layer of 25 units. Cubing means multiplying length, width, and height. We stack 4 identical layers on top to fill the complete interior capacity. 5 times 5 times 5 results in 125. This process stacks two-dimensional areas into the third dimension to determine the object's total internal capacity. Step 4 is identifying the correct units. It is possible to perform the math correctly, but fail the problem by applying the wrong dimensional units to your answer. This chart highlights the difference. On the left, because surface area measures flat space, the unit is squared. Our answer is 150 centimeters squared. On the right, volume measures three-dimensional space, requiring a cubed unit. This gives us 125 centimeters cubed. To stay accurate, always match the exponent to the dimensions of the space you are measuring. 2 dimensions for area and 3 dimensions for volume. Step 5 involves the surface area to volume ratio. This is a critical metric used to understand efficiency in both biology and physics. In biology, a cell's internal volume grows faster than its surface area. If the ratio drops too low, the cell can no longer absorb enough nutrients through its membrane, forcing it to divide to survive. We calculate this by dividing our surface area of 150 by our volume of 125, resulting in a ratio of 1.2. For cubes, you can use a mathematical shortcut to reach this same conclusion. Simply divide 6 by the side length A. By plugging in our side length of 5, we get 6 divided by 5, which is exactly 1.2. Understanding this ratio allows scientists and engineers to determine the scaling limits of objects in the physical world. Take a look at your scratch paper. You have just derived 3 distinct data points from a single starting measurement. This confirms our work. From a 5 centimeter edge, we calculated a surface area of 150 centimeters squared and a volume of 125 centimeters cubed. To test your progress, pause the video and calculate the surface area and volume for a cube with a side length of 8 centimeters. Share your results in the comments. By isolating the side length, following the order of operations, and matching units to your dimensions, you have accurately defined the spatial properties of a three-dimensional solid.